students, so welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today is Sunday and as promised every Sunday we launch the mock test, right? So yes, now we'll be discussing the solutions of mock test 11 where we gave you questions from the chapter Some Basic Concepts of Chemistry and Structure of Atom, right? So I hope all of you would have downloaded the question paper, solved the questions, and now it's time to check your level of preparation, okay? So you need to see the solutions, check your answers and assign +1 mark for every correct answer and 0 marks for wrong and unattempted questions, okay? So yes, now students, let's get started with the first question. The first question was very easy. That is the number of protons, neutrons and electrons in the given ion, okay? So you can see here that is 16, atomic number is 16, so we can say that protons will be 16. So you can eliminate this option, right? Next you have neutrons, so 32 minus 16, that is also 16, so we can eliminate this option. So protons, neutrons, proton, neutrons. Now you say 16 protons are there, so 16 electrons should be there, but we have a 2 minus charge, that means 2 extra electrons, so number of electrons will be 18 here, so that is why correct answer is option number B, okay? Second question is very similar to this. The number of electrons, protons and neutrons in a species is 18, 16, 16. So the symbol, so you can see here that there are 18 electrons, so definitely there will be a 2 minus charge, right? So we can eliminate this option and this option, so that is why option number A here. Next, question number 3. An ion with mass number 56 contains 3 units of positive charge and 30.4% more neutrons than the electrons. The ion is, okay, this is a very important question. Let us solve it. So it is saying that the mass number is 56. Now what is mass number? So if you see, mass number is what? Number of protons plus number of neutrons, right? Now mass number is 56, that means we have how many number of proteins? So you have protons. So it says that it has 3 units positive charge, okay? So let us assume that the number of electrons is x, okay? Let us assume. Now if you see that the positive charge 3 units means 3 electrons have been lost, right? That is why we have 3 positive charge. Then what will be the number of protons? Number of protons will be x plus 3, right? And what we can say about the number of neutrons? 30.4% more neutrons than electrons. So I can say that 30.4% of x plus x, right? So now we can solve this equation. So let me try to this. So I'll get 130.4 x, okay, by 100. Then I added these two. 1 second. Okay, so I can have here 131.4. So I'll add it together and write down. So we have here 100. So I can say that we'll take 100 as LCM. I'll get 100x plus this side 100x plus 30.4x, right? And I have left with this plus 3. So if I solve this, I'll get 100, 230.4 divided, so 2.304x plus 3 is equal to 56, okay? Now if I subtract this, it will be 53 equal to 2.304x, and now if I solve it, x will be something equal to 23, okay? So if x is equal to 23, then what will be the number of protons? Number of protons will be 23 plus 3, that is 26, and we have only one option with that, so correct answer will be option number B here. Okay, next, in the following set of ions which is not isoelectronic with the rest of the species. So isoelectronic means the number of electrons should be same, right? So if you see here, oxygen has 8 plus 2, 10, here 9 plus 1, 10, sodium has 11 electrons, so that is not isoelectronic, option number D here. Next, question number 5. The atomic number of the element with highest ionization energy among the following is, okay? So you need to find the highest ionization energy. So if you see Z equal to, okay, so Z equal to 16, Z is equal to 14, Z equal to 13. So you need to write their electronic configuration. Let us do that. So if you see, we have 1s2, 2s2, 2p6, 3s2, right? 6, 7, 8, 9, 10, 11, 12 and 3p4. Next, Z equal to 14, you have 1s2, 2s2, 2p6, 6, 7, 8, 9, 10, 11, 12 and 13, 14. Z equal to 13, it is 1s2, 2s2, 2p6, 3s2 and 3p1, right? So 6, 7, 8, 9, 10, 11, 12 and 13. For 15, I will have 1s2, 2s2, 2p6, 3s2 and 3p3, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, if you see, this p orbital is exactly half filled, right? So, if it is exactly half filled, then what will happen? It will have a stable electronic configuration. So, ionization energy will be maximum here. Answer will be option number D. Okay, next question. If a wavelength of photon is this much and h is given this much, then the momentum of the photon is, okay. So, momentum of the photon, you know the formula, lambda is equal to h by p. So, p will be equal to h by lambda. So, h is 6.6 into 10 to the power of minus 3 and minus 34, and this one is 2.2 into 10 to the power of minus 11. So, I will get 3 into 10 to the power of minus 23. Option number C here. Next, two particles A and B are in the motion. If the wavelength associated with A is this much, wavelength associated with B whose momentum is 1/3 of A. Okay, so this is again from your de Broglie wavelength. So if you see here, we have lambda A is given to you as 33.33. Okay, lambda B we need to find out. PA is given 1/3 of PB, right? So whole momentum is 1/3 of A. PB momentum is, we'll do it again. So lambda, so lambda A is 33.33. Lambda B we need to find out, and we have PB equal to 1/3 of PA. Okay. Now what is the relation here? If you see, lambda B by lambda A will be inversely proportional to PA by PB. So I can put lambda B equal to PA by PB into lambda A. Now what is PA? PA, okay, by 1/3 PA is equal to lambda A is how much? 33.33 nanometer, right? So I can write into 10 to the power of minus 9 meter. Okay, options are in meter, so I converted it. So I'll get here 99.99 into 10 to the power of minus 9 meter. Okay, 99.99 is nothing but 100. 100 into 10 to the power of minus 9. So 10 to the power of 1 into 10 to the power of minus 7. That is option number D here. Okay, 2 I will get 2 minus 9 minus 7. Yes. Next, a body of mass 10 milligram is moving with a velocity of 100 meter per second. The wavelength you need to calculate. Okay, so we need here lambda is equal to h by m into v. M is how much? 6.63 into 10 to the power of minus 34. For joule we can write kg meter square second inverse. Okay, second square. Okay, joule, second inverse, second kg meter square second square, and then we have here joule second, right? So one more second is there. So I am writing in, so see here h value is 6.63 into 10 to the power of minus 34 joule second. This joule unit can be written as kg meter square second square. Okay, and then this s is present as usual. Then we have mass is 10 milligram, so we can convert it into first gram. If I convert, so it will be 10 into 10 to the power of minus 3, then gram to kilogram, again 10 to the power of minus 3, so it will become 10 to the power of 6 kg. Okay, and then velocity is 100 meter per second. Okay, so now let us try to calculate. So I will get here, this is 10 to the power of 3 minus 6 plus 3, 10 to the power of minus 3 I will get, right, into 10 to the power of minus 34 plus, here I got 6, this is minus 3, if it goes up it will become plus 3, so I will get 6.63 into 10 to the power of minus 31. Okay, that is option number B here. Next, the number of angular and radial nodes of 3p. So if you see here 3p, right, so what is the formula of angular nodes? Angular nodes is L, right? So and radial nodes is n minus L minus 1. So here your n is 3 and L is 1. right? So if I take 3 minus 1 minus 1, that is 1, and here also it is 1, 1 and 1, that is option number B. Next, the statement that is not correct. Azimuthal quantum number signifies the shape. Yes, correct. Energy of the stationary states in the hydrogen like atom is inversely proportional to principal quantum number. That is also correct. Total number of nodes in 3s is 3. No, total number of nodes is n minus 1. So 3s means 3 minus 1, that is 2. So the incorrect statement is option number C. Okay. Next, the number of radial and angular nodes for the d orbital are represented as. Okay, so for d orbital, if you see, the L value is 2, right? And we have, we need to find radial nodes. So radial nodes formula is n minus L minus 1. So L minus 2 minus 1, that is n minus 3, right? So radial nodes will be n minus 3, n minus 3. So we can eliminate these two options. Now what is angular nodes? That is 2. That is L value. So angular nodes will be 2. Here also angular nodes is 2. Now what is total nodes? Total nodes will be n minus 3 plus 2, that is n minus 1, right? So n minus 1 total nodes, option number D. You need to add the radial and angular nodes. Okay, next, with regard to photoelectric effect, identify the correct statement. Okay, number of electrons ejected increases with the increase in the frequency. No, it increases with the increase in intensity. Here it increases with the increase in work function. No, increase with the increase in intensity. Yes, so option number C here. Next, the orbital nearest to the nucleus. So you know, the less is the n value, closer it is to the nucleus. So these two will be there, and out of S and F, S is more penetrated. So option number C. Next, the energy of the electron in the nth orbital of Bohr. So the minus 13.6 n square, that is direct formula based, option number A here. Next, assuming Rydberg constant are equal, the ground state energy of the electron in hydrogen is equal to, okay, so we need to check whether it is equal. Okay, so if you see the ground state of hydrogen atom energy state is minus 13.6 by n square, right? So that is 1 square, so I can say minus 13.6 by 1 square, that is equal to minus 13.6 eV, right? Now if you check here, first excited state of, the ground state energy of helium, option number A. So minus 13.6 Z square by n square formula, right, for hydrogen like atom. So hydrogen helium, Z is 2, so minus 13.6 Z square, okay, by ground state means it is 1, so these two values will not be same, so this is not the answer. Next, you have the first excited state, so minus 13.6 Z square is 2, okay, and first excited state means again your 2 square, so this will get cancelled and that will be equal to this one. So option number B is the correct answer. Next, energy associated with the first orbit of helium plus. So again minus, we need to do in the calculation in the form of 2.8 into 10 to the power of minus 18 Z square, okay, by with the first orbit. So n square is 1 square. So 4 8s are 32, 4 1s are 3 plus 1 7, 4 2s are 8, 8.72 into 10 to the power of minus 18 joule, option number, okay. So we need minus, okay, so not option number A, it will be option number D, minus 8.72. Next, which of the following electrons transition in the hydrogen will release the maximum number of energy? So here you can see that when you jump from 6 to 2, you are taking a lot of difference here, the energy levels are more, so energy released here will definitely be more. Option number D will be the correct answer, okay. You can check it like this, we will get minus 13.6, just you need to check like this, 1 by 2 square minus 1 by 3 square for option number A. Option number B is minus 1 square by 1 by 2 square, then minus 13.6, here we will get 1 by 2 square minus 1 by 5 square, and then minus 13.6, 1 by 2 square minus 1 by 6 square, okay. So you will see this value will be the highest. Next, the energy associated with the first orbit of helium plus, so that we just now calculated, minus 8.72 into 10 to the power of minus 18. Next, the correct set of quantum numbers for the unpaired electron in the chlorine. So chlorine, it has 3p5, right? So the last unpaired electron is present in 3p, right? So if you see here, n value is 3, L value is 0, 1, okay. So we have n value, L value should be 1, so that is why option number D should be the correct answer. Next, which of the following statement is incorrect? Okay, so about quantum number, the shape of an atomic orbital depends on the azimuthal. Yes, it is correct. The orientation of the atomic orbital depends on the magnetic. Yes, this is also correct. The energy of an electron in an atomic of multi-electron depends on the principal quantum number. No, if you know, the energy depends on n plus L, right? Whichever n plus L value is higher, its energy is maximum, and if n plus L value comes together or comes same, then the one which is having more n value will have highest energy, right? So it depends on both n and L. So that is why here the correct answer or the incorrect statement will be option number C. Okay. Next, 21. A pure compound contains 2.4 gram of carbon, 1.2 into 10 to the power 23 atoms of hydrogen and 0.2 moles of oxygen. The empirical formula is, okay. So let us first calculate the number of moles of all. So carbon number of moles is given mass by molar mass, so that is 0.2. Number of moles of hydrogen is number of atoms, right, divided by the Avogadro number of atoms, that is also equal to 0.2. And number of moles of oxygen is also 0.2. So the ratio is 1:1:1. CHO, option number D is the correct answer. Okay, next, a gas mixture contains 25% of helium and 75% of CH4 by volume at a given temperature and pressure. The percentage by mass of methane in the mixture is approximately. Okay, so we need to check that, let the total volume, okay, let the total volume be 100. Okay, then in that we have helium, how much? Helium is 25, okay, and we have methane is 75. Okay, so what we can do, we can find the number of moles of helium, that is 25 divided by 22.4. okay, so we'll get I think 1.1 something, and number of moles of methane will be 75 divided by 22.4. so this one will be somewhere around 3.3 number of moles we got. Now let us calculate the mass of helium. So mass of helium will be molar mass divided into the number of moles, right? So 1.1 into 4, that is 4.4, and here number of moles of CH4 is 3.3 into 16, right, molar mass of this one. So 16 3s are 48, 48 plus 4 is 52.8. so we got now weight of helium is 4.4, weight of methane is 52.8. what is the total weight here? So we have here 57.2, right? Now you need to calculate the percentage of CH4, right, methane percentage you need to calculate. So what is the weight of methane? 52.8 divided by 57.2 into 100. okay, so now if you solve it, it is like 528 by 572 into 100. okay, so I think if I just add one 0 here, okay, so I think let us try to divide it. 528 divided by 572. I just need to know the one digit, right? Okay, so let us try with, if I multiply with 5, so 5 2s are 10, 5 7s are 35, plus 1 36, 25. So I can go more. Let us try with 7. 7 2s are 14, 7 7s are 49, 50, 7 5s are 35, plus 5 somewhere around 40. Let us check with 9. 9 2s are 18, 9 7s are 63, plus 1 64, 6 9 6s are, so 9 5s are 45, plus 6 51. So we can go up to 9. So that means 92%, option number B here. Okay, next, 0.4 gram of dihydrogen is made to react with 7.1 gram of dichlorine to form hydrogen chloride. The volume of hydrogen chloride formed at 273 Kelvin and 1 bar pressure is. Okay, so the reaction is like this. H2 plus Cl2 is giving you 2HCl, right? 0.4 gram of dihydrogen and reacted with 7.1 gram of HCl, right? Now if you see the number of moles, given mass by molar mass, here it is 1 and here also 0.1. okay, so 1 mole of hydrogen reacted with 1 mole of chlorine to give you 2 moles of HCl. Then 0.1 will react with 0.1 to give you 0.2 moles of HCl. right? Now 0.2 moles of HCl, if I want to calculate into volume, so molar volume I need to multiply 0.2 into 22.4, so it is 4.4 0.48, right? 1 second, 2 4s are 8, any calculation error we took here. 0.4 gram of dihydrogen, so molar mass is 0.1, is made to react with 7.1 gram of chlorine, so its molar mass 0.1 to form hydrogen chloride. The volume of hydrogen chloride formed at 273 Kelvin and 1 bar pressure. Okay, so we got here the mass of chlorine is 7, given mass by molar mass, so 0.4 by, okay, here I did a mistake. Okay, so this is the mistake here, that 0.4 by 2 is 0.2, right? So here number of moles is 0.2, this is 0.1. So that means 0.1 will react with 0.1 to give you 1 second, let me do this calculation again. Okay, let us do step by step here. Some calculation error, I think. So we have dihydrogen mass is 2 grams, right? So what is the number of moles of hydrogen? Given mass by molar mass, so that is 0.2. Okay, next what is the mass of chlorine? Okay, 35.5 into 2, so that is 71. Okay, so what is the molar mass of number of moles of chlorine here? 7.1 by 71, that is 0.1. Okay, now the reaction is balanced in this way. So we have the number of moles here is 0.2 and this one is 0.1, right? So now 0.1 will react with 0.1, so this much H2 will left behind, means, and we will get 2 moles of HCl, right? So for every 1.1 mole of chlorine, we are getting 2 moles of HCl. So if 0.1 moles of chlorine is reacting, we will get 0.2 mole of HCl. Okay, then the question is asked to calculate the volume. We can easily convert it into volume. Gram of dichlorine, volume of hydrogen is produced. Okay, so if I see here 1 mole is giving you 2 moles, so 0.1 will give you 0.2 moles of HCl. Okay, now let us try to convert it into volume. So 0.2 into 22.4. So I have 2 4s are 8, 2 2s are 4, 2 2s are 4. 4.48 liter. Okay, so it will be near to around 4.54 liter, because sometimes this 22.4 is also taken as 22.7. If you take 22.7, you will get 4.54 here. Okay, next, the mass of AgCl precipitate when a solution containing 11.7 gram of NaCl is added to a solution containing 3.4 gram of AgNO3. Okay, so we have here AgCl reacting with the mass of AgCl precipitate. Okay, we have the reaction between NaCl and AgNO3. So NaCl plus AgNO3 is reacting to give you AgCl, right? So now a solution containing 11.7 gram of NaCl is added to a solution containing 3.4 gram of AgNO3. Okay, so let us calculate the masses quickly here. So we have here number of moles of NaCl will be, what is the mass of NaCl? We have 23 for sodium and chlorine is 35.5. So if I add them, I'll get 3 to 58.5, right? So 11.7 divided by 58.5. And next, if you see, we have here 3.4 divided by AgNO3 mass is 108, okay, and nitrogen is 14 and oxygen is 48, right? So 8 plus 4, 12 plus 8, 20, then we have 4, 5, 6, 7 and 170. Okay, so I think this I can cancel out. 17 tens are 17 twos are, right? So 0.02 moles here, and let us check, we can cancel this one in any way. 5 7s are 35, 5 1s are 3 plus, yeah, so this one will be 1 by 5. 1 by 5 means 0.2. Okay. Okay, so 1 mole is reacting with 1 mole, so 0.02 mole will react with 0.02 moles, so 0.02 mole will form 0.02 mole of AgCl. So AgCl formed here will be 0.02 moles because this is the limiting reagent, right? Now 0.02 mole you need to calculate in mass, so just calculate the mass of AgCl, that is your 108 plus chlorine is 35.5. right? So 5, 8 plus 5, 13, 3 plus 1, 4, 143.5 into 2. So 143.5 into 0.02. So we will get 2 5s are 10, 2 3s are 6 plus 1 7, 2 4s are 8, 2 1s are 2, then so we will get 2.87, that is option number C here. Next, 1 gram of magnesium is burnt in 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess? So we have Mg plus O2, okay, giving you 2 MgO. So now if you see, we have 0.28 gram of oxygen. So 0.28 divided by 32, that is the number of moles here, and 1 by mass here is 24, that is the here. Now if you see, we need like I can say in terms of mass. If I tell in terms of mass, let us not convert it into moles because question is given in terms of mass, right? So I can say 48 gram of magnesium is reacting with 32 gram of oxygen, right? So 1 gram of magnesium will react with 32 by 48, that means your 16 2s are 16 3s are, so I can say 0.6 something. Okay, now how much gram of magnesium is present? So 1 gram will react with 0.6 gram, right? That means, and oxygen is only 0.28. So definitely oxygen, yeah, so 1 gram is reacting with 0.6 gram of, let us check the calculation once again, 24 2s are 48 and 32, okay. So 48 gram is reacting with 32 gram, 1 gram will react with this one. Yes, so definitely oxygen is the limiting reagent here, right? So now how much oxygen will be left out? So how to calculate that? So I'll write like this, that 32 gram of oxygen is reacting with 48 gram of magnesium. 1 gram will react with 48 by 32, that is 1.5 gram, right? 16 3s are 16 2s are. Then how much oxygen is present? 0.28 gram will react with 0.28 into 1.5. So let us solve this. We can just calculate this one. So 2815, if I multiply, so I'll get 14, 1 8s are 1, 2s are 2, so I'll get 0, 420, so I will have 0.42, right? So 0.42 gram of magnesium will be reacting, right? Then how much will be left? 1 minus 0.42, so that is 0.58. Okay, so option number B will be the correct answer, which is left in excess, it is asked, right? Okay. Next, if 3.01 into 10 to the power molecules are removed from 98 milligram of H2SO4, then the number of moles of H2SO4 left is. So if you see here, first we can calculate number of moles of H2SO4, right? So that is what? 90 given mass by molar mass gram by 98 gram, that is 10 to the power of minus 3. Okay, how many number of particles? Number of molecules will be 6.022 into 10 power 23. So I can write 6 into 10 to the power of 20. Okay, from that 3 is removed, so 3 will be left, right? So number of molecule left will be 3 into 10 to the power of 20. And if you want to calculate in terms of number of moles, I will get 0.5 into 10 to the power of minus 3, right? Option number A. Next, an organic compound contains 6C 40%, H 33.33% and N 46.67%. Its empirical formula is, okay. So if you see here, carbon is 40, hydrogen is 13.33 and nitrogen is 46.67. Then you need to convert it into its molar mass. So 40 by 12, 13.33 by 1 and 46.67 divided by 14, right? Now once you get these numbers, you need to calculate the simple ratio and then you have to calculate the final value and you will be getting around CH4N, okay. Next, the number of oxygen atoms in this many grams of carbon dioxide. So 4.4 divided by 44 is 0.1 moles, right? 0.1 mole into number of oxygen atoms. So we have, okay, so how many molecules of O2 will be present? So 6 into 10 to the power of 23, and in each there is 2, so into 2. So I will get 6 2s are 12, 1.2. So that is option number A, right? Why I multiplied 2 here? Because in each molecule of carbon dioxide there are 2 molecules of oxygen. So first, when I multiplied up to this, I converted the number of moles of carbon dioxide, then into 2 to calculate the number of oxygen atoms. Next, what amount of dioxygen contains these many 1.8 into 10 to the power 22 molecules. Okay, so I can say that 6 into 10 to the power of 23 O2 molecules are present in 32 grams, right, the molar mass. So one will be present in 32 by 6 into 10 to the power of 23, and then this one will be present in 1.8 into 10 to the power of 22. Okay, so we have here 32, right? So I can calculate, this is 0.3, 9.6, so 0.96, so that is option number A. Next, 0.3 gram of an organic compound contains C, H and O. On combustion gives you 0.44 gram of CO2, 0.18 gram of H2O. So now see, this carbon dioxide which is produced, this carbon must be in the hydrocarbon that is taken here, right? So I can say that number of moles of carbon is 0.44 divided by 44, so that is 0.11. Okay, now if I want to calculate number of moles of hydrogen, okay, so our number of moles of hydrogen will be, how number of moles of water first if I get, that is 0.18, okay, 0.18 by 18, that is 0.01 into 2 I need to multiply because 2 is there, so you can say 0.02, okay, so it is 0.1. So now what we can expect from here? So we can expect here one thing, that okay, 0.01, right? So we can expect here that the carbon and hydrogen moles will be double, right? The moles of hydrogen should be double than carbon. So if you see here, this is not there, and yeah, we have another thing here, this is also not there. Here it is double, here it is double, but the molecular mass is 60. But here if you see, the molecular mass is not 60, here it is 60, so that is why option number B is the correct answer. Okay, so yes students, thank you, and I hope you have enjoyed, you have done all the questions correct. So let me know your comments in the comment section, your scores. Okay, thank you for watching and subscribe the channel.